Hi guys, this is George from DoraHacks and welcome to another DoraHacks workshop hosted by Minda Network. Today's episode will be hosted by Dr. George, co-founder and CTO of Minda Network. At DoraHacks, we are very proud to host this workshop together with Minda Network on Web3 data science and its fundamental challenges. For a brief introduction into Minda Network and Dr. George, Minda Network is a groundbreaking platform that leverages the power of blockchain technology to create a secure and decentralized network for mental health professionals and patients alike. With its innovative approach to mental health care, Mind Network is poised to revolutionize the industry and improve outcomes for patients around the world. At the forefront of this exciting development is Dr. George, a renowned mental health expert and co-founder of Mind Network. With over 20 years of experience in the field, Dr. George brings a wealth of knowledge and expertise to the platform and is dedicated to improving the lives of patients through innovative and effective mental health care solutions. For anyone in the YouTube or Binance Live chat rooms, please feel free to ask questions as we go, and I'll ask these to Dr. George later on. Without further ado, let's welcome Dr. George. Thanks for joining us today.
Thanks, George. My name is also George. Yeah, and very glad to join this session. Let me start to share my screen first. Okay, hopefully you will be able to see my screen sharing. And if there's any, if not, then just let me know. Okay. Yes, yeah. So I think George already see a lot about me. I will focus all the time on the presentation and also on the technology and also on the challenges we're going to say. So firstly, I wanted to jump into the main topic straight away. The background of this presentation is about data science and particularly on Web3. If you are less familiar about data science work, you may ask, what is data science? I mean, right now, it's very popular to ask ChatGPT. If you do this work, you are already in touch of data science because ChatGPT is an AI product. The model has been trained based on a very large scale of data, could be public available in order to train this model. And AI is part of the data science. When people talk about data science, broadly, it could be, let's say, a data analyst. It could be like a data engineer, business analyst, or machine learning engineers or AI engineers. If you say it narrowly, when people talk about data science, it's mainly about the AI or machine learning engineers. Okay, but no matter what, data science has become a very popular term. I think around from maybe 2008 or 2010, because at that time the data availability has been significantly changed. And also the fundamental technology behind, for example, the very large-scale data warehouse or data lake technology has been developed and also matured in able to get a very complex answer from the large scale of the data. From then, the job market for the data science has been significantly increased. Technology company, financial industry, they're all looking for data science. In terms of technology stack, they were using R, Python, and also Spark, Hadoop, and also other type of technologies over here. So those are the information you probably already experienced or can be explored online. Okay. But to be honest, the data scientists will continue to be popular because people realize more and more value to do the data mining or to become a kind of data-driven services and also the product. Okay, so then the next question is, okay, why Web3 should focus on data science? Why they should care about? Okay, ChatGPT. If you ask this question, they will give you an answer. I'm not going to through details because those are more kind of a business or marketing languages. I would like to talk more in technology details. We need to review what is data science in the technology level. So in terms of technology, data science normally will split or assemble task into pipeline. We call it data science pipeline. And a typical example, I attach a screenshot over here. It will collect or capture data from different data sources. For example, from cloud, from IoT devices, from storage, or even from your mobile phone, or could be any other places also. They will be stored and also being processed in a centralized places. We normally call it as a kind of data warehouse or data lake. Okay, and right now the popular data processing technology, we are using Hadoop, Spark. If it is streaming computing, then Flink, Kafka, all those kind of technologies. And then data transformation will happen inside. For example, to clean the data, change the format, or doing a logic conversion, make this into a usable and also meaningful KPI. And then if it is for recommendation or credit score, risk modeling, those kind of work will come up with you the final results. And then sending to different representations, for example, to user, to dashboard, and to others. Okay, if you look at Web3, it's exactly same right now. For example, a lot of the founder management company or investment company, or even the crypto website DFs, they are also doing the same way. For example, they will get the data from online or offline. They will crunch the data, they will process data, come up with the KPI, and then showing this to the user in their DApp or through API and passing to the downstream applications. Okay, but Web3 coming with a different way to using the data, because some of the data they are not centralized being stored. It could coming from a decentralized Oracle service, or could coming from a smart contract. Okay, but fundamentally, if you look back in Web 2, the data they are in plain text. In Web 3, the data coming from on-chain or off-chain, they are also in plain text. What does that mean? That means like if you giving the data, if you getting those plain text, or if you giving your plain text to others, you are kind of losing control for your plain text, because you will be difficult to know how and when your data will be used. Think about you have a lot of data on Google or Facebook. To be honest, it's very difficult to know how they're going to use your data and when they're using your data, right? So what I'm trying to say is, in the future, if there is a fundamental assumption going to be changed, which is the data, what happens if the data is not a plain text anymore, and if they are going to be the ciphertext? Will the data science work to be the same, or to be very challenging if we move into that world? And to be honest, this world will coming over very, very soon. Firstly, right now, if you look at the big company, technology company, they are already facing the regulatory challenges. Some regulation like GDPR, which require those platforms to specifically get the permission from the user in order to using their data. Even they already have the data, but they still need to get the permissions. And people's awareness on the privacy has been increased year by years. Even look at the Web3, people care about privacy more and more. Right now, maybe because there's no kind of ciphertext computing technology, But once this come over, user will prefer their information not going to be disclosed in a plain text on the on-chain, right? Okay, so this I would say this year will definitely will come over, and then our question is, okay, this will change the fundamental assumption, and what technology do we have, and what solution do we have? Okay, so we as a Minda Network, we assume to working on the ciphertext, and we are aiming to provide a privacy preserving data lakes, because data lake or database or even data warehouse is the fundamental for the data science work. Okay, let me move to the next slide. Okay. Okay. This market is a big market, as already said. Here are two figures we searched online. For example, there is about 169 billion spending already on the data protection last year. And Harvard Business School also predicates that by 2030, the data economy going to be 13 trillions. Okay, but remember, you and me as a data owner, as the user, we get very little benefit or economic monetary benefit out of these big markets. Okay. Industry has been trying towards to this direction in several ways. So, for example, they are throwing other cryptography technology, but not on the still on the plain text in order to solving these problems. Or some of the technology companies they are using AI, or they are moving towards AI in order to get more kind of value from data. But Minda Network, we are positioning ourselves as we want to focus on the fundamental challenges and specifically working on data lake related domain in order to support a more privacy preserving related use case on top of us. Okay, so that is where we're coming from, and in order to conquer this market as we grow up. Okay, so let me move on to next one. So what is Minda Network? In a one sentence, Minda Network is a decentralized privacy preserving data lake by the people and for the people. It has a team of computer science PhD and also hardcore software engineering. Team members are graduates from top universities worldwide, and also has many years of experience on internet company and security startups. But all of us are sharing the same mission to solving these challenges, and we are all data enthusiastic. So that's our team member, and this is a kind of quicker view of our product, a screenshot. So we are aiming to bring a kind of secure data ledger with serverless experience, but based on the ciphertext. And we want to have like 4 features for the users. The first one is easy to use, because we don't want to reinvent the wheel. Okay, data lake, the current, even from the data lake from Web2 is already being popular and widely used. Okay, there are a lot of benefits. For example, auto scale, high performance, those kind of features already being developed. We are not going to change this completely. What we do is just to replace the fundamental engine. Rather than process on the plain text, we make it into a process on the ciphertext. So we can reuse the larger benefit already or advantages already being developed from the Web2 data lakes. Okay, so we will make it easy to use, same as other data lake you already being used. Secondly, is it's going to be open. We're going to open this, and so everyone in the community, they will be able to use, to develop, and also to contribute on this. It's going to be it's also going to be a decentralized version also. So that means like it will solve the current challenges in the data lake product, which is they are centralized. They will have a management cluster to control the whole clusters. What we will do is to rewrite the network and also consensus engine, make this into decentralized data lakes. Okay, so that will make the service to be and it will be maintained and also supported by the whole community, and that is how it's going to become a serverless product or service to the community. Then the third feature we are looking for is to make it to be secure. As we said, we want to work on the ciphertext, which is from the day one. We are not be able to get users plain text or get users secret from day one. So security is one of the I would say the fundamental character in our team for this product. As a new product or as a good product, it needed to be fast also, because if it is slow, then why not a Web2 product which is already high performance? Okay, so in our lab environment, the results we have been achieved through the benchmark is already a big jump, but we're continue working to make it more and more faster and faster. Okay, so then you may ask, okay, how do you exactly work on ciphertext? How do you make ciphertext be able to compute? Okay, in a high level, we have the team has been dedicated into HFHE technology for a while already. So HFHE is short for homomorphic encryption. It is mass approved and being developed very fast in the last few years, and it's going to be ready for the production soon. Okay, so what does this exactly doing? Okay, with this technology, user, for example, they will encrypt their data locally, okay, with their own kind of secret keys, and then they will pass. They will using this they make this plain text into a ciphertext, and then pass this ciphertext into the remote server or remote node. Okay, let them to process those ciphertexts on a remote node. Okay, so that means remote node, they will not be able to touch on the plain text because they cannot decrypt, because they have no key to decrypt. Okay, but they can conduct a calculation on those ciphertexts. For example, they can add them together, or they can do comparison and other operations, computing operations. You are working on the same plain text. So once they finish the process, the results will also be in ciphertext. Okay, and then the ciphertext results will be sending back to the user in their local environment. And then the data owner who get those ciphertext results, because they have the key, so they will be able to decrypt the ciphertext into a plain text, and then showing or sharing or passing to other process. Okay, so this is exactly how the HFHE is going to work. It's going to do the data processing on ciphertext, and then any user who are on the left, which is will be able to say the plain text is because before sending to the server, they will do the conversion from plain text to the ciphertext, or after receiving the ciphertext results, they will be able to decrypt into a plain text. Okay, so that is a very, I would say, illustrative way to explain how the HackHatch work and how we're going to make this work. So what we have done is we using this technology, and then to modify the computation algorithm and also the engine for the data lake already being popularly used. Okay, so that means like for the calculation, they will process on the ciphertext, but all the above, for example, query engine, for example, the cluster communication, and also the auto scale, those kind of capability which already available on the data lake, will be able to continue to use. But we're just changing the fundamental engine part. Okay. You may feel that there are also other technology, for example, ZK, zero knowledge, they already been popularly used for the privacy preserving. Okay, over here, I'm not going to go to a very detail, okay, but just quickly saying that ZK and HackHatch, they are different mechanism and also the implementations. Okay, HackHatch, we are basically confident to share the ciphertext with others. So this will be particularly important for a database or data lake, because a data lake needs to have your, for example, larger scale of your data or all your data, and then in order to do a query or calculation. For example, if you want to develop a recommendation engine will likely to prefer to have all your data in order to make this model accurate. Okay, so this will be particularly require the data ciphertext going to be exchanged between different parties. Okay, ZK is more for kind of approval or kind of verification. We haven't been able to see that it's ready to exchange a large amount of data already. So it's two different dimensions and also for different purposes. Okay, in a summary, we are HackHatch is mainly for the computation, and this has been required or demanded in Web2 also a lot. Particularly, for example, if you consider for the cloud computing, why financial industry or government they are not confident to bring their data into the cloud. That's because they are still not be able to approve that cloud computing is only doing outsourcing work. That means like they will not be able to touch on my sharing, my secret, but they only be able to process on the ciphertext. Okay, so this is the exactly same demand, same as what we are doing over here, and then let the data processor to process on the ciphertext. Okay, so this technology, as we said, Web2 and Web3, they are all demand, and the data lake we are developing is for mainly for Web3 because it has the decentralized feature, but Web2 from the development we already made. Okay. Seeing a lot, I was wondering why not giving a specifically use case for you, and maybe that will be easier to follow. Okay, so we joined a hackathon a few weeks ago with our technologies, and it is about the social file, and it is asking, okay, what is missing in the social file? Why the Web3 social file cannot be become same as popular or as a large amount of users, same as like a Web2 social network. Okay, because you know that Facebook, Twitter, and others, they have large amount of the user. But if you look at the social file, the total number of user or the active user DAU, they are not high. Okay. In that hackathon, we did some brainstorm, and we think maybe one of the feature is currently missing is in social file. If you want to upload some of your photo, it's going to be public available, and then everyone be able to see. Probably you also even cannot be able to delete because it's permanently stored on chain. Okay, so we think that Web3 currently they have some concerns like below. They will lose a kind of a very firm control of the photo that have been shared or uploaded to the social file platform. And what happened if those upload is mistake? Can they really delete it? Or if those photo whether it will be if it is a photo without any kind of encryption, whether other people will using my photo for bad purposes. Okay, and if I'm going to use if there will be a kind of multiple social file platform, I really don't want to upload photo across different platforms, which is exactly same as like in Web2. I need to share, upload my photo to Facebook, giving my photo ownership to Facebook. I may also share this, upload this to Twitter, and then Twitter will be able to see my photo as well. In the future, can we make this into a kind of user-centric rather than a platform-centric? And okay, particularly if I want to store some of my private data, which I don't want to public share, but also I'm worried that it's going to get lost one day in my laptop or mobile phone. But if it is a centralized photo sharing services like Dropbox, one day if they're going to disappear, where am I going to be able to get those photo back? So all those kind of questions user may concerned. But what we are thinking is, okay, could be one of the reasons is user not be able to encrypt their photo as a kind of default. We studied that and also developed some a prototype to solving these issues. What we have developed is a kind of a privacy protected photo sharing solution for social file, and particularly for the UGC related content and also protocol in the future. So this hackathon is organized by Stackware and also Musk. And we win the second prize in that hackathon with the demo. So what we exactly have been implemented is we assume, okay, two person or even a group of peoples. Okay, over here we find a photo which is on Google Images. This is a photo which is taken by CZ and Sam together. I think this is a couple of years ago. They met in somewhere and then take this photo. And in this photo, you can see they are very happy and also shake hands. Okay. So in our scenario, if there's a social file, if there's a social network for Web3, one of them, for example, CZ will upload this photo to the social network. Okay, and then public sharing with others. But in the future, if one day, if they are really, friendship is broken, this photo without any kind of encryption, it will be stored there forever. Like what we can store on Google image search right now. This photo, after a few years, I can still see it. Okay, what we want to implement is when CZ upload his photo with Minda Network, he will only be able the photo will be encrypted. For example, we can detect all the face, okay, and then blur all the face, okay. This is just one example in our hackathon demo, but it could be other important. It could be other kind of AI model being used. For example, to blur out the whole whole body, or or like a kind of those kind of company brand belonging, all those kind of information. It could be others. Okay, but anyway, over here we are just using an open source face recognition model. So once those face has been blurred, it will upload to the social network, and it can be publicly shared because face has been blurred. Those kind of biometric information has been taken out. Okay, and then this photo can only be shared with his friends. So that means like through some social network DID solutions, they will be able to specifically tell us, okay, whether those two people they are friends or not. Okay, if they are friends, they will be uncover or recover the face from the masked photo. So, for example, for the photo above, they will be able to see each other. But if one day their relationship has been broken, they unfriend with each other for whatever reason, we don't know. Okay, from that time on, because they have no relationship, then they will not be able to see each other's face also. So this will make, at least will reduce people's confidence that the photo has been shared on the social network. It's all been kind of blurred with the important information. But we also give them the capability that one day, if they want to recover based on certain conditions, their face will be shown. Okay, so this is what we said. Okay, photo is one of the plain text. We can make it into ciphertext, and then can do the processing in the data warehouse, and then it will be able to decrypt for the data owner who have the key or have been shared access for the ciphertext. Okay, so in summary, we want. In this use case, we have been able to demonstrate that this solution will be no more kind of privacy leak in photo sharing, because all the photo has been encrypted, and then it will have like this end-to-end decentralization without intermediate, because our solution is going to be a decentralized, and then user have like full control for the information rather than the platform. Okay, and in this particular demo, we will be able to bring AI into the system to perform other work on top of the data warehouse, and to make this data science work to be pipelined and to be continually enriched for different scenarios. Okay, so I have a demo over here. So this demo already been shared on the GitHub for in our project repos. And so George, I don't know how much time do we have? Shall we go through this demo, or we should conclude our presentation, my presentation soon, and leave some time for the questions? What's your thought? Okay. Okay. Yeah. George said yes. Okay. I think George get disconnected. Okay. So in that case, I will quickly show this demo and then waiting for George to come back. Okay. Hopefully you will be able to see my GitHub repo. So in this demo, because we are data scientists, okay. So this is a data scientist. So we are using a Jupyter notebook, which is very popular by the data science. Okay. So in this data science, this notebook, we have been showing exactly step by step how we're going to using Minda Network and also to solving this private photo sharing use case. So those are the just preparation work. And over here, I'm using a name called Alice. So he has a he has been taking this photo one day when they meet each other. It's like kind of selfie. Okay. Okay. So he has these images. I'm just showing these images. It looks like this. Okay. So Alex will upload this photo into Minda Network, and also will get a return of the masked photo, and this masked photo will be ready for the public sharing. But in this photo, you will be able to see that all the important features, for example, face, has been blurred. Okay. And then he will be able to check the original photo in the Minda Network, and then he will also be able to share sharing to a social network. Okay, this photo has been shared after clicking the clicking the button. The sharing has already been integrated with some social network API already. Okay. So this photo has been shared through the social network, and then social network will only maintain or contain this masked photo, and then everyone anonymously or not their friends not be able to see and the face in the post with this masked photo. Okay. We did another work which is also because face recognition, we also wanted to do other work. For example, be able to recognize who is in that photo. So for Alex, we upload another photo, and then to capture the importance or the feature importance for his face. Okay, so then we can use this to recognize his face in other photo that maybe is not uploaded by him, but cross over the internet. Okay. So Bob, which is Sam, they are doing the same. Why we're doing this work? Because we want to using this work to detect a random photo, not only the photo being uploaded by them. This is for the kind of privacy leak, to prevent the privacy leak. Okay, and then we're connecting to the other kind of DID providers. So the DID providers, it will be able to tell us whether they are friends or not. Okay, so at that time, they are friends. So they will be able to see each other by recover the photo already being masked. Okay. Of course, we can also, if there are other information, for example, a name, they can also be tagged into the photo. As I said, if one day, okay, their friendship has been broken, for example, Sam decided to leave CZ, they are not friends anymore. So when CZ log in, he will only be able to see his face, but not be able to see Sam's face. Okay. Equally, if Sam log in, then he will not be able to see this face also. And this will be the dynamic. That means like everything connecting through a Minda Network and also the social file, they will be able to, once this unfriend happens, it will be applied across all the social network. So the user will have one control to all the social network. That's because they're going to connecting, but the decryption will only the decryption needed to go through by users. Okay, so that's the a kind of a demo written in Python and in Notebook, and then welcome for you to have a look. And then if you have any comments, please share with us. Okay. Let me come back to the PowerPoint. Okay. Okay. So where we are, okay, we are currently developing our product, and it's going to release soon, and we are open source. So then the ecosystem will be able to benefit and also contribute on top of us. Okay, and we are looking forward to to have more and more kind of communication with the community, either through our official channel or through our partnership. For example, this time with by getting this opportunity to share our progress over here. But in the meantime, we are backed by the incubation program and also the builder program by the big names over there. They recognize our technologies and want to also give us a lot of support and help to make this technology to be developed and then pushed to the market. To be honest, this is a pairing. This is I would say a very challenging work, because you will not be able to see similar product in the market at this moment. You will see other data lake related project, but not specifically on a cipher text. So we are the team taking the challenge to resolve these fundamental assumption problems. Okay, so I think I'm going to stop over here and let the team continue to stay tuned. And if any question or if any comments, please do share with us. We are really looking for more user and also partner and also advice on how to help us to moving forward. Okay, I will stop here. Okay.
Fantastic. Thank you, George, for your presentation. I had a couple of questions for you. So, first question that I had was, how does my network solve data breaches, and how is AI and blockchain going to help with that?
Sure. Okay. So for the data breaches, over here, as we said, we are taking your ciphertext. So basically, in our side, in terms of the storage, in terms of the network transmission, and also in terms of the data processing, they are all in ciphertext format. We are not be able to get your plain text at all. Okay, so the data breach will not happen in our side. Okay, of course we cannot control, for example, on users' local environment, whether they will be hacked and then get the data being breached. But in our side, we are not be able to do that work at all. And that is why we want to take these challenges, because as long as your data is in the plain text, there will be an opportunity to make the data breach happens. And that is what I think one of the fundamental assumptions we need to change in order for the data science work to be continually be able to process large amount of the user data. Because when user privacy become more and more important and user aware of the privacy control more and more, okay, it could be happen that there will be a less chance for the data science work continue to work as a Web3. Okay, so we want to challenge on this foundation for this assumption, and then also be prepared for the future Web3 data science work. George, did I answer your question?
Yeah, fantastic. The next question I had was, how does my network make sure that performance is in a decentralized data lake?
Okay, yeah. Firstly, we are reusing lots of the well-developed high performance algorithm or mechanism in Web2 data warehouse already. So, for example, the high availability, recovery, auto scale, all those kind of skills work already being done will be able to reuse. Okay, so this already make the performance to be high, and what we have done is to change the fundamental engine. Okay, and our focus is to make this engine to be fastest. So there are a list of the fine-tuning algorithm and also the mathematical. So, for example, the kind of vectorization, those kind of techniques to solving the performance. Okay, I'm not going to through the too much details today. It's going to be explained well in the white paper. How about this, George? I stay in this high level right now.
Yeah, no, that's fine. That's fine. Not a problem. And the last question I had was, what are you guys planning on building in the next, like in the near future, and what's kind of the roadmap in the coming months, and also the next big milestone? I mean, it's probably all a part of the same kind of question.
Yes. Okay. So I mean, it's lucky we are just stay on this page. So in our plan, we're going to launch our test network. So this will be able to do the demonstration as what we do as what we did in the in the hackathon, and also so this will be the fundamental infrastructure work going to be ready. And then we will adding more and more work, and also fine tuning to improve the performance, to make it a kind of production ready also. So that will take some time to reach the second milestone. Okay, then the third milestone is to come up with talking to more kind of partner, and also building together with the ecosystems to understand what exactly missing in order for the ecosystem to benefit from the Minda Network. So we will come up with the solution, and then also the integration to support other ecosystems work. So that's going to depend on whether it's going to be this year or next year. But I would say stay tuned with us. Okay, we will have more and more kind of milestone information going to be released. The lucky thing is we have already, for the fundamental research and also development work, we are already, I would say, kind of 90% already being there. Okay, so we are ready to go. Yeah.
Perfect. Thanks, George. So that concludes our workshop for today. So thank you everyone for joining us today, and a very special thank you to Dr. George for sharing his insight into Web3 data science and its fundamental challenges. And we really do appreciate your time and efforts for bringing us such a wonderful workshop today. On DoraHacks, we have got a range of sessions like today's coming up in the future, and we also have hosted previous sessions in the past, which are available for you to watch on our YouTube channel. So for all of the audience, if you are interested and haven't followed us on YouTube or Binance Lives, please make sure that you do so you don't miss out on any of the upcoming sessions that we're going to host for you. So thanks again for joining us today, and as a very special thanks to you, George, and we look forward to seeing you guys again in the future. So thanks, guys. And also, sorry, if you want to get in touch with our community and with DoraHacks, please make sure to follow our Twitter, Telegram, and join our Discord as well. The QR codes here on the screen are available for you to scan and join and get in touch with us, and also get in touch with Minda Network as well and join their communities as well, as I'm sure they would love to hear from you and have you there. So thanks again, guys.
Thank you. Thank you, everyone.
Thanks.